Now coming to the properties of carboxylic acid. Now lower carboxylic acid, they are, what you find is that they are liquid. The lower carboxylic acid, it's not gaseous, it is liquid. Lower means, I mean to say, formic acid, acetic acid, and propanoic acid, we can say that. Clear? They are pleasant smelling, colorless liquid, we can say that. Of course you will say that vinegar is pleasant smelling. So to say, it's not. If not, it is a good smell. It's also not bad smell. That also you can say that. Clear? So it's a colorless liquid. But after that, butyric acid. Got it? Formic, acidic, and propanoic. They do not have what you can say bad smell. So to say, whatever it is. It is having a pleasant smelling. It's a colorless liquid. But butyric acid means butanoic acid. It smells like rancid butter. Rancid butter means जब butter जब खराब हो जाता है. Got it? Clear that it smells like that. Rancid butter. It has got a smell of rancid butter. We can say that. Butyric acid. It has got a foul smell, and still the foul smell increases as the number of carbon atom goes on increasing. We can say that. And as the number of carbon atom goes on increasing, I've already said you, that is, it becomes solid. So hence it is called as higher carboxylic acid. Is also called as fatty acids. I've already discussed with you. Alright. So, but the benzoic acid, it's aromatic acid, benzoic acid, but it has got no smell. It's a colorless solid, remember it, with no distinct odor. Alright, benzoic acid. Clear? Colorless solid, no distinct odor, benzoic acid. Clear? Even if it is coming under aromatic acid. Now solubility, if you see, then that carboxylic acid, it is soluble, the lower one. Why? Because they are able to form intermolecular hydrogen bond with water. But as the alkyl group goes on increasing, the hydrophobic character goes on increasing and the solubility decreases. Alright, the lower one is soluble in water. Alright, due to its polarity, not only its polarity but also due to the formation of intermolecular hydrogen bond with water, it is soluble in water. But as the number of alkyl group increases, means from formic, ethanoic, propanoic, butanoic onwards, you will find the solubility goes on decreasing. Why? Because the alkyl group, the number of carbon atom increases, and alkyl group are hydrophobic in nature. So as the alkyl group goes on increasing, the solubility goes on decreasing. So the lower carboxylic acids, I mean to say, they are highly soluble in water. Alright, the lower carboxylic acid. Clear? So in this way you can explain it. For example, you can see here RCOOH. You can see. So here it forms intermolecular hydrogen bond with water. Now, not only it forms intermolecular hydrogen bond with this oxygen, but also it can form intermolecular hydrogen bond with this oxygen also. It can form. So for that reason, the low carboxylic acid, the solubility increases. But as this alkyl group goes on increasing, alright, the solubility decreases because hydrophobic character increases. We can say that. Clear? So in this way, the lower carboxylic acid is highly soluble in water. Fine. But in case of aromatic carboxylic acids, it is less soluble. Generally, benzoic acid you find, it is soluble in hot water. It is not soluble in cold water. Alright, benzoic acid. Because benzoic acid, what you find is that is bigger group. It's a bigger group. So bigger group will, what you can say, will not allow the water molecules to come closer to each other. Alright, it will not allow. And it will also not allow to form intermolecular hydrogen bond with water. If at all it forms, it will be a weak intermolecular hydrogen bond. And it will, what you can say, unstable in nature it will be. For that reason, benzoic acid is not soluble in cold water. It is soluble in hot water, we can say that. Got it? So solubility decreases. In case of aromatic carboxylic acid, it is not soluble there. Then it is soluble in what? It is soluble in alcohol, polar solvent, alcohol, benzene, toluene, ether, in this way. Alright? So those are carboxylic acids, whether it is aliphatic or aromatic, whose solubility is much less than water. Alright? It's more soluble in polar, what you can say, sorry, non-polar solvent. I'm very sorry. It's not polar solvent, it is non-polar solvent. Non-polar. That is, which is alcohol, benzene, toluene, ether, etc. It is means soluble. We can say that. Clear? In this way, you will be finding it out. Now, next is if you see the boiling point, then carboxylic acid has got higher boiling point compared to the corresponding alkanes and alcohols. Alright, alkanes are no doubt non-polar in nature. So definitely carboxylic acid will have higher boiling point than the corresponding alkanes. Means, for example, let us say ethanoic acid has got higher boiling point compared to ethane. Not only it has got higher boiling point compared to ethane, but also it has got higher boiling point compared to ethanol, we can say that. Compared to alcohol, we can say. Clear? Why? Because carboxylic acid, what I said you, it not only forms intermolecular hydrogen bond with this oxygen atom, but also with this. Alright, let me write in this way so you can understand it. So as a result, it forms dimer, RC. Let me write it properly, this one, RCOOH. Now you see here, another molecules, that is acid molecules, carboxylic acid molecules, we can say that, it also forms dimer. Alright, see, it forms a dimer with, this is one carboxylic acid, this is another carboxylic acid. So it forms intermolecular hydrogen bonding with this oxygen atom as well as with this oxygen and hydrogen atom, we can say that it forms. Hence, it results in the formation of dimer, that is association of molecules. So, when you are, what you can say, breaking the bond, you are not breaking the bond of one particular intermolecular hydrogen bonding. You are breaking the bond of two intermolecular hydrogen bonding. So, definitely more energy will be required, due to which the boiling point is higher than the corresponding alcohols and what you can say, alkanes. Alkanes are non-polar, alright, no doubt about it. So, definitely carboxylic acid is polar in nature. Alright, so it will have a higher boiling point, but compared to alcohol, because alcohol only forms one intermolecular hydrogen bond, understood? It is forming in this way, you can say that. See, this is case of alcohol, which I have already studied. In case of alcohol, it forms in this manner, we can say that. One goes with another. Alright, it does not form association of molecule, it does not form dimer in case of alcohol, but in case of carboxylic acid, it forms dimer, it undergoes association of molecules, due to which more energy will be required to break the bond, and hence more energy as it is required, boiling point also will be more. So hence carboxylic acid is having higher boiling point compared to corresponding alcohol and alkenes, so to say, we can say that. Now next is melting point. If you see, then carboxylic acid has got melting point also higher, but it is in a zigzag manner. Alright, that means the carboxylic acid having even number of carbon atoms have got higher melting point, and the carboxylic acid having odd number of carbon atoms. Listen carefully now. Carboxylic acid having even number of carbon atoms means ethanoic acid, butanoic acid, hexanoic acid. They have got higher melting point compared to methanoic, propanoic, pentanoic in this way. Why? Because when it has got even number of carbon atoms, then the carboxylic acid is symmetrical in nature, symmetrical, and hence they can be tightly packed. They can be tightly packed in this way. It is being symmetrical. Let me draw it and show it to you. It is symmetrical, so hence it can be tightly packed. As it can be tightly packed, so more energy will be required to break that particular bond. Alright, see here. For example, 1, 2, 3, 4. You can see it is symmetrical. CH3, CH2, CH2, butanoic acid. But if I draw it for pentanoic acid, propanoic acid, or pentanoic also will do, no problem. So here you can see it is unsymmetrical in nature. Unsymmetrical. So when it will be symmetrical, due to symmetry, it will be tightly packed. This molecule, this is butanoic, symmetrical, even number. It will be tightly packed, closely packed, due to which more energy will be required to break the bond, because symmetrical means closely packed, tightly packed, strong intermolecular force of attractions. So definitely for that particular reason, carboxylic acid having even number of carbon atoms have got higher melting point than carboxylic acid having odd number. Because in odd number you can see it is not symmetrical, it is unsymmetrical in nature. This is unsymmetrical. Now you will say how it is symmetrical? This is a line of symmetry. This one is a line of symmetry, you can say that, because it is forming a regular figure, we can say that. Of course here also it forms, but we don't have any line of symmetry here. Alright, in this way, remember it, carboxylic acid having even number of carbon atoms have got higher melting point than carboxylic acid having odd number of carbon atoms, due to its symmetrical nature when it is tightly packed, closely packed, having strong intermolecular force of attractions. Similarly, aromatic acids also, for example benzoic acid, also have got higher melting point. It's solid, na? Benzoic acid is a solid, just now which I said you. Why it is then having higher melting point? Because in benzoic acid, the benzene ring is planar. The benzene ring is planar in case of benzoic acid. So planar means it can fit into a plane. Alright, the benzene ring packs more closely in the crystal lattice because it is planar. It can, what you can say, that is fit into a plane. Number of benzoic ring can fit into a plane, due to which, as I said you, just like as it's symmetrical, here also same thing, it is planar. So it can closely fit into a crystal lattice, due to which more energy will be required to break the bond, and hence it has got higher melting point. So Aromatic acids also, that is your benzoic acid also have got higher melting and boiling point. The reason is that the benzene ring is said to be planar in nature. It is planar in nature, benzene ring, so it is more closely packed in the crystal lattice compared to the zigzag carbon chain. Here, see, zigzag carbon chain of the aliphatic, what you can say, acid, we can say that. Clear? So hence, that is aromatic carboxylic acid is also having, for that reason, higher melting point and boiling point than the aliphatic carboxylic acid. Listen carefully. Aromatic carboxylic acid have got higher melting and boiling point due to the aromatic carboxylic acid. Because aromatic is also closely packed, but it is planar. It fits more closely, more tightly into the crystal lattice. Lattice means definite geometrical structure, you have studied. Compared to the zigzag ring of the aliphatic group, we can say that. Alright, here also it is tightly packed, but here it is more closely packed. Compared to this, it is more closely packed, and hence it has got higher melting and boiling point. It has got lower melting and boiling point. Alright, clear? In this way, we can explain the properties of, the physical properties of carboxylic acid. Thank you.